The final part of the quadratics units in Year 10 is on quadratic inequalities. So to start with, what we'll do is explore a linear inequality and apply the same strategy to quadratics. So we're going to sketch y equals 2x plus 4. So we've got a y-intercept of 4 and an x-intercept of x equals negative 2. So there's our linear function. All right, so with quadratic inequalities problems, I want you to note the strategy that we're going to use to solve these series of questions. For what value of x is y equal to 0? So y is equal to 0, that's the x-intercept. Okay, so that's going to happen pictorially here at x is equal to negative 2. And that's along this line here because that's when y is equal to 0. Y is equal to 0, I go across and I go, oh, there it is. That's when y is equal to 0. Now, for what values of x is y less than 0? Let's go along this line here and note that this is when y is equal to 0. This section of the Cartesian plane, all of this bit here has the values of y that are less than 0. Look at them. There's y as negative 1, negative 2, negative 3, negative 4, negative 5, etc., etc. So we're looking in this section here to find out when y is less than 0, and we're wondering what values of x this occurs for. So this is when y is equal to 0 at x is equal to negative 2. It's going to be for the values of x less than negative 2. All right, so that's going to give us a y value less than 0. Now, how can we test that? Choose a value of x less than negative 2. Why not choose negative 3? Here's negative 3, and notice that the y value is negative. Negative 4, the y value is negative. Negative 5, the y value is negative. So it's for all the values of x less than negative 2. For what values of x is y greater than 0? So this portion of the Cartesian plane here is when y is greater than 0. It's all of these values here. Again, if you look at all of these y values here, 1, 2, 3, 4, 5, these are all positive numbers. And if you look at this point here, we're going to say that for any value of x larger than negative 2, what you're going to get is a y value larger than 0. All right, so we're going to say that it's for all the values of x larger than negative 2. For what values of x is y less than or equal to 0? Now, if we're including that point there, it'll be for x less than or equal to negative 2 because we're allowing 0 to also happen there. So, ever wonder why you flip the inequality when dividing or multiplying by a negative? Let's sketch this particular function now. So we've got 4 as our intercept, negative 4, x is equal to 2. That's our y-intercept over there. Yeah, try that again. It's a bit better. All right, what value of x is y equal to 0? It's going to be when x is equal to 2. So that's y equals 0. This is when y is greater than 0. This is when y is less than 0. For what values of x is y greater than 0? So if you look here, it's for all the values of x less than 2. Okay, so all of these values here less than 2 will produce a y value larger than 0. So if you check it out, like if you sub in 0, which is less than 2, 0, negative 2 times 0 is 0, 0 plus 4 is 4. The y value is more than 0. What values of x is y less than 0? All right, so it's less than 0 for all the values of x larger than 2. For example, 3, 4, 5, etc. All of them will give you a y value of less than 0. So we're going to say that x greater than 2. All right, finally, for what values of x is y greater than or equal to 0? Okay, so greater than or equal to 0 will be all of these values over here. So that's going to be for x less than or equal to 2. All right, solve the following algebraically. All right, negative 2x greater than negative 4x. Now, if we don't flip the inequality here, what we're going to do, and this is basically saying when are the y values going to be larger than 0? Okay, and we know we've answered this already. This is when y values are larger than 0. The answer to this should be when x is less than 2. we don't flip the inequality here, what's going to happen is we get x greater than 2. Now, that's obviously a problem because we know that the y values are larger than 0 when x is less than 2. So how do we make this true? What we're going to do is say that we've got to flip the inequality here to make this true. So we're going to answer x less than 2. And that's the reason why we flip the inequality, because otherwise graphically it wouldn't be true. So we're going to use this graphical approach to solving quadratic inequalities as well. So it says here to solve anything other than a linear inequality, you must sketch the graph. Take a look at the graph. All right, so sketch the following and notice that we're not concerned about the actual turning point or the y-intercepts. Thus, it's allowed to be a rough sketch, or what I say, we draw crap graph. All right, so here's this particular equation here. And what we want to know is when are the y values, or for what value of x is y equal to 0, greater than, less than, and greater than and equal to. All right, so let's do the crap graph. So the x-intercepts are going to be at 3 and -2. All right, if I solve via the null factor law. It's an upright graph, so we draw it like that. Now that is a terrible graph, okay? But it's a means to an end. What it's going to allow us to do is to answer the following questions. So along this line, y is equal to 0. Above the line, y is greater than 0. Below the line, y is less than 0. For what values of x is y equal to 0? Go along the line, and it's equal to 0 at x is equal to -2 and x is equal to 3 at those two values. Now, when is it going to be greater than 0? So for what values of x will the y values be more than 0? Well, here it is. It's going to be when x is less than -2. So when x is less than -2, what we're going to get is y values that are more than 0. When x is greater than 3, we're also going to get y values more than 0. So we're going to say when x is less than -2 and x is greater than 3. What values of x is y less than 0? So it's going to be less than 0 between -2 and 3. We can see that all of the values of y here are all going to be less than 0. So we're going to say that it's between -2 less than x less than 3. So for the values of x between these two values here, what we're going to get is y values that are less than 0. Finally, for what values of x is y greater than or equal to 0? So we're allowing 0 to be included here, which is going to be exactly the same solution as this one here, except we're going to say that it's less than and equal to and greater than and equal to 3. So we're allowing 0 to come out and the values beyond that as well. All right, so solve the inequality. This is what most students do, or many students do. So the classic error here is students try to solve it algebraically. All right, so what they get when they go ahead and solve algebraically is x greater than 4 and x greater than -2/3. Okay, now you notice here that x greater than -2/3 also covers x greater than 4. So this is wrong. Okay, and what we're going to do is follow the advice that appeared at the end of this page. To solve anything other than a linear inequality, you must sketch the graph. Okay, it's mandatory. You've got to do it. So the better approach will be to knock together a crap graph. What we're going to do is get the x-intercepts, which is 4. The other one is -2/3. Now notice that the scale is completely off. That doesn't matter. I'm only sketching the graph to answer the question. And this question says, when is this going to be larger than 0? So remember that this is when y is equal to 0, this is when y is larger than 0, and this is when y is less than 0. We want to know when it's larger than 0. And it's going to be in this part here and in this part here, right? Because the x values given here produce y values larger than 0. So the answer to this question is going to be for all the values of x less than -2/3 and for all the values of x larger than 4, we're going to get a y value that's larger than 0. Right, solve the following. We will not ask you to sketch it, but you must sketch it. Okay, so let's do this one here. And again, apologies for the formatting. In the Word document, it looked fine, but just doesn't, for some reason, the PDF does something to it. All right, so we're going to grab the x-intercepts and draw my rubbish graph. Okay, it doesn't matter about the scale. So we want to know when it's less than or equal to 0. All right, so here is, along this line is when y is equal to 0, above the line is when it's greater than 0, and below the line is when it's less than 0. All right, we want less than and equal to 0, which is going to be below and inclusive of the points. And that's going to be for the values from -3 inclusive of -3 all the way up to and inclusive of 5. All right, so that's when that one is going to produce y values that are less than or equal to 0, between -3 and 5 inclusive of the points. All right, this one here is a bit of a tricky one here. So we're going to grab the x-intercepts, which are 1, and 4x take x is equal to 0, negative x equals -4, x is equal to 4. Our other intercept is at 4. Now, what we've noted here is that the two that I've drawn are upright parabolas, but this one here, if you notice that this negative happens here, that's what will happen when I expand this one is I'm going to get negative x squared. And remember, when I've got a negative sign out the front of the squared term, that means I've got an inverted parabola. So this parabola is in fact inverted. Another way to think about this is to rewrite it as negative x take 4, x take 1 greater than 0. You'll note that this is 4 and this is 1, and we've got an inverted parabola. All right, now what we'll do is look at when we want this true for. So it's when it's greater than 0. So along the line is when y is equal to 0. Above the line is when y is greater than 0. And below is when it's less than 0. We want it when it's greater than 0, which is this part here. It's for the values of x between 1 and 4. All right, what about this one here? So what we're going to do with this one here is actually sketch it. Remember, we need the x-intercepts, all right, and this doesn't have the x-intercepts. So let's just quickly factorize it. So 5, 3, x, and that, I believe, will be the negative. X take 3, x plus 5, greater than or equal to 0. All right, no dramas. Now let's do the crap sketch. 3, and -5. It's an upright parabola. There it is. All right, so now what we want to do is ask the graph when these conditions occur, and we want greater than or equal to 0. So it's equal to 0 along the line at those 2 points, and it's more than when we hit below -5 and above 3. So it's going to be when x is less than or equal to -5, and when when x is greater than or equal to 3. All right, over here, let's do this one. So this is negative. Let's pull out a negative, x as a factor, and x plus 6 less than or equal to 0. All right, our x-intercepts via the null factor law will be at 0 and -6. This negative sign means that it's negative x, which means it's an upright parabola, inverted parabola rather. All right, so now we want to know when it's less than or equal to 0. All right, so it's going to be 0 there, and less than, so this along the line is when y is equal to 0, above the line is when y is greater than 0, below the line is when y is less than 0. So it's there and there. The answer to this is going to be when x is less than or equal to -6, and when x is greater than or equal to 0. All right, a few more. All right, this one here looks to be quadratic formula. Okay, so what I can quickly see is, is it quadratic formula, or will this never happen? All right, I think I might have been cheeky when I wrote this example here. I'm going to run the discriminant check. B squared take 4ac is the discriminant. Discriminant is 9 take away 4 times 1 times 3. Discriminant is 9 take away 12. Discriminant is -3. All right, so this does not have any x-intercepts. So what's going to happen with this graph here is it has a y-intercept of 3, and it's going to look either like that or like that. Now, what we're asking this is, when are you less than 0? This is when y is equal to 0, this is when y is greater than 0, and this is when y is less than 0. Okay, and what we're actually trying to do is find out when the graph will produce, or for what values of x will we produce a value of y less than 0. Now, have a think about it, girls, and maybe pause the video, because what we're asking it is something that's very difficult to answer. Right, if you've had to think about that, what you'll note is it's never going to happen. Okay, so when is this going to happen? Never. Okay, it will never occur. Okay, because the values of x that you feed this equation here will always produce a y value larger than 0. All right, let's have a look at this one here. So what we've got is a graph. -3 is the x-intercept. It's an upright graph, and that's basically the y equals x squared graph moved 3 units to the left. And we want to know when it's going to be less than or equal to 0. Well, it's equal to 0 along that line there. It's greater than 0 above, and it's less than 0 below. So it's only going to be less than and equal to 0 at one point. X is equal to -3. It's going to be equal to 0. It's never going to be less than it. So that's the only value for which this will satisfy the inequality. All right, 2 more problems here. So we've got this problem here, which will be quadratic formula, I suspect. So what we're going to do is get the x-intercepts of this parabola. X equals, so the quadratic formula is x equals -b plus or minus the square root of b squared, take 4ac, all over 2a. We'll give you that formula, so you don't need to memorize it. -b is -3 plus or minus the square root of b squared, which is 9, take away 4 times a times -3, all over 2a, which is 2. X equals -3 plus or minus, so that's -12. 12 negated is going to be root 21 over 2. All right, now let's sketch our graph, which is an upright graph. I've got one x-intercept at -3 plus root 21 over 2. The other x-intercept at -3 take root 21 over 2. All right, so there's my x-intercepts. And what we want to know is when the graph is larger than 0. So there's y equals 0, there's y greater than 0, there's y less than 0. Okay, so when does it occur? We want it to be less than 0, and it's between these values here. So I'm going to say between -3 take root 21 over 2 less than x less than -3 plus -3 plus root 21 over 2. So between those values there, what we're going to get is y values that are less than 0. All right, what about this one here? All right, we want to know when this graph here is less than -12. That's really hard to do, okay? So what we're going to do is add 12 to both sides and then solve a different equation. So we're going to go x squared take 3x, and we're going to add 12, which gives us -32 greater than 0. So this is the one that we're going to solve. All right, now what we'll do is just check out whether that factorizes. 8. I think I might have, when I add 12, oh my God, I can do basic arithmetic, can't I, girls? 28 is my answer there. All right, so 28, 7 and 4, which you subtract is 3. All right, we've got a winner there. That's the negative. So it's going to be x take 7, x plus 4 greater than 0. All right, crap graph time. 7, -4. Don't worry about the scale. It's a means to an end, this graph. All right, we're asking this graph the question, when are you larger than 0? This is when y is equal to 0. This is when y is larger than 0. This is when y is less than 0. We want larger than, which involves those 2 points there. So x less than -4 and x greater than 7 will satisfy this original equation. Okay, so that's when this graph here will be greater than -12 is for these values of x. All right, the final question is this one here. x squared plus 3, and we want to know when that's greater than or equal to 0. So crap graph time, this is the x squared graph, move 3 units up, and we want to know when this happens. When is it larger than 0? This is when y is equal to 0. This is when y is greater than 0. This is when y is less than 0. When does that happen? All the time. Okay, all the time. So we can answer this for all x. Okay, for every value of x, the y value is going to be larger than 0. So every single value for x satisfies this inequality. Okay, now what we would do next year is we would say something like between negative infinity and positive infinity would be a possible way to do that. But for this year, all I expect you to do is to say for all x, or for every value of x. And you can put that in words, that's fine. All right, the calc does inequalities as well. So we can ask the calc questions. Let's just do this one here. So we can go solve x squared plus 3x, take 3, and we want to know when it's greater than 0. And recall that you get the greater than symbol in Math 3. So there's all the inequality symbols. So greater than 0 for x, and we'll go into standard mode. All right, and we've got our solutions there, which is, they look a little different. They've kept them split, which is fine. Okay, so x less than that. Yeah, that's how the calculator says between values there. That's a bit clumsy, isn't it? Yeah, the calculator is saying basically, yeah, between those two values. All right, so there is a worksheet for this. You'll see the link on Firefly, so grab the worksheet and move your way through it. Check your answers with the solutions or calculator.